This is just a short video on the properties of limits before we jump into solving limits analytically, which is the third way to find a limit. Out of the book, this is Chapter 1, Section 3. So the first couple things are just the limit of some constant number as x approaches some value is just going to equal that constant. The next one, or let me give the example for that one first. So the limit of 3 as x approaches 5, that's just going to equal 3, because remember that this right here is a function. If you graph y equals 3, then everywhere on the x, at every single x value, the y value is going to equal 3, which means the limit is going to equal 3. The limit as x approaches c of x is just going to equal c. So the limit as x approaches 5 of x will just equal whatever c is, and that's 5. In the next video, that's actually going to be explained with something called direct substitution. The third one, limit as x approaches c of x to the nth power is going to equal c to the nth power. So if you have the limit as x approaches 5 of x squared, that's just going to equal 5 squared, which equals 25. And finally, just a trig function to show you that that these same properties still apply to trig functions. The limit as x approaches c of sine of x is just going to equal sine of c. So pretty much when you see an x in your function, you're going to plug in whatever value they give you for c. So for the example for this one, the limit as x approaches 0 of sine of x is going to equal sine of 0. The sine of 0 is just 0. Next are just some limit rules that you can use. In these several cases, we're going to be following the idea that the limit as x approaches c of f of x is going to equal L, and the limit as x approaches c of g of x is going to equal k. So number one, this is called the scalar multiple. The limit as x approaches c of some constant times the function is just going to equal that constant times the limit of the function. So say this b was a 3, and say and then that would just, you could just bring this out to the front since it doesn't have any variables in it, and then it would be 3 times whatever the limit of f of x as x approaches c equals. The second one, the limit as x approaches c of f of x plus or minus g of x, so that's just saying one function plus or minus a different function, is going to equal the limit of one of the functions plus or minus the limit of the other function, depending on whatever this sign is right here. Pretty much just saying split it up and find the limit as x approaches c of f of x, and then find the limit of find the limit as x approaches c of g of x, and then do whatever the sign tells you, whether to add or subtract, and you just do that with whatever the limits came out to be. Number 3, same thing as number 2 except multiply. Just solve each piece individually and then multiply the two. So limit as x approaches c of f of x times the limit as x approaches c of g of x. And that's pretty much what L times k is saying. Number 4, the limit as x approaches c of f of x divided by g of x is just going to equal the limit of f of x divided by the limit of g of x. So long as the limit of g of x does not equal 0, or else in that case it would be undefined. And the last one is the power rule. This one is sum or difference. This one's product, quotient, and power rule. So limit as x approaches c of some function to the nth power is just going to equal the limit of that function to the nth power. Hopefully all that made sense. When we start in the next video, we're going to learn something called direct substitution. That'll hopefully clarify all of this up because you'll actually see it in application. So yeah, just go ahead and check out the next video. If it still doesn't make some sense, then feel free to comment or message.